So now we can start with the session. So now today we are going to start this chapter, this new chapter, which is matrices. Okay. And I hope you guys know that the unit is matrices and determinants. But what we will be doing is we will first cover matrices, and after that we'll come to determinants. So we have to study this unit as together. But before determinants, we need to learn matrices first. Okay. So the important thing is to know, like, why do we use matrices? Okay, like what are matrices, and before that we also need to know that why do we use matrices. Okay, so all of you just let me know, like, do you have any idea about regarding matrices, like what is matrix, what is a matrix, and why do we use it? Anyone? Okay, so suppose like there's a hint also, like there are two equations written, linear equations and two variables. Okay, 2x plus 3y is equals to 5, 4x plus 5y is equals to 9. So you can solve this equation. Each one of you is able to solve this system. Why? Because two equations are there, two variables are there, and you know the tricks, like you know the elimination also, substitution also. Okay, but what if, like, we just introduced one more equation? Okay, like this is a new system. Okay, now are you able to solve this system? Like all the tricks that you have studied is for linear equation in two variables, but now there are three equations. There is this mathematical rule which says that the number of variables must be equal to the number of equations. So if there are three variables involved, that means we need a minimum of three equations to solve. Okay, so yes, we have three equations and three variables. So how do we solve this? So this system can be solved using two methods. So the first method is Gauss elimination. That I am not going to tell you, obviously not, because this is just an introduction to the chapter. But yes, some of you might have this idea about Gauss elimination. So this Gauss elimination is a method which is used to solve the system of linear equation in three variables. But it is a very lengthy process, because in that process what we actually do is we just reduce these three equations into two equations, and then we can solve the two equations using that same old technique, which is elimination either or substitution, right? But it is the time complexity of Gauss elimination is very large, like it consumes more time. So now if we want to solve a system of three linear equations, then we can do this by using matrix method. So that is the one prominent reason. Sorry sir, I joined late as I was eating. Hari Mahesh, you can say sorry, but you don't have to specify the reason also, that I was eating. That's fine. Okay, I'll manage. Okay. So yeah, what I was saying is that while I was talking about the solving the system of these three equations now, so we can do this by matrix. Yeah, that is not the only reason that we are learning matrices, but yes, this is one prominent reason that matrix could be used to solve the system of three equations. Like it will be very easy and it will be very short also. So solving these three equations is not easy by any method except matrix method. So before before you learn this now, there is more important thing, which is introduction to matrices. So in this lecture we will be covering each and every detail of matrix. Okay, there are certain operations also, so that we'll discuss on next term, and there are certain things which are related to this matrix, so we can discuss this in like later on. Okay, but in this session what we are going to learn is, so first of all, the basic of matrix. Okay, bilkul from zero level. Okay, and in this lecture we'll be covering about types of matrices. That is very important for JEE also, because in JEE there are certain questions which are directly linked to the theory, and that theory is not mentioned in any CBSE book. Okay, so you will not find that in NCRT, you will not find in RD Sharma also. So some of the terms and some of the like notations are there, which I'll be telling to you. So fine, we can start with the session. I hope sufficient participants have joined. But please, everyone, just turn on your cameras and mics. Come on, do it quickly. Adil, just turn on your camera. Jyotsna, just turn on your camera. Kyle, Trivikram, yes. Okay, students, let me know. Like, I have assigned one class assessment test to you and homework to you of that ITF, inverse trigonometric functions. Have you gone through the both the tests? Have you attempted both the tests? Obviously, I can see that in my dashboard also, but right now I'm in the lecture, so I won't do that. So rather I'll just ask. Have you guys attempted? Hari Mahesh, you tell me, you attempted the test? Both class assessment as well as homework also. I attempted CA, sir, not yet done homework. Okay, fine. So those tests will be pending for you. Okay. So don't make it a like large count. Like when the test is assigned to you, so it's a duration of 1 week. So you can cover it in like 1 week only. Okay. Yeah. Fine. Why everybody is like still uh, turned off their camera? Jyotsna, please turn on your camera. Dhameshwar, please turn on your camera. Darshan, Kyle, and Adil. All the 5 participants, just turn on your camera. Fine. Because I won't be knowing now, like what is happening in the other end. So you need to turn on your cameras. Okay? Fine. So why do we use matrices? Matrix method are used to solve linear equations in 3 or more variables. Sir, I have some issues with my camera, sir, kindly excuse. Okay, that's fine. So you have to say that now. That's okay. Okay, so what do you mean by matrix? So matrix is an arrangement of rectangular array of horizontal lines and vertical lines consisting equal number of elements. I am damn sure that by this definition you are not going to get anything. Okay, so I'll write it for you. See, like some elements, see what do we call elements? Elements are just numbers only. Okay, suppose I have like 2, 3, 4, 5, 2, 3, 4, 5, 6, 7, 8, 9. Suppose I have, okay, one more, 10. Suppose I have these 6 numbers with me. Okay. Now, what if I just randomly arrange these numbers? So that is not going to form any matrix. So in order to form a matrix, I must write these numbers in a pattern, in a proper pattern. So that pattern is a rectangular array. Okay. For example, I can write this like 2, 3, 4, 5, 6, 7, 8, 9, 10. Or I can also write it like 2, 3, 4, 5, 6, 7, 8, 9, 10. So like I have written these 2 arrangements, right? The numbers I have written in these 2 arrangements. So these are just a matrices, right? So the representation of a matrix is you need to put these square bracket sign, okay, and inside that elements will be written, and that elements will be of like they will be of forming proper pattern, okay, like it will be a rectangular or square array, okay. See, Just like this, in this example, what we have done, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 numbers are written, but they are in the proper pattern. Okay. I'm sure you got that point. So 1, 2, 3 is there, 4, 5, 6 is there, 7, 8, 9 is there. So each element is just behind the previous element and the proper flow is maintained, the proper pattern is maintained. See, you can see the proper pattern using these red dotted lines. So the arrangement of elements of matrix is enclosed by the brackets. Okay, so now we have these brackets also as well as these brackets also. So now earlier we had only this kind of representation, that only in the square bracket we have to write the matrix. But now we have two notations. So we can use either this or this also. Okay. So generally there is a name for matrix. Suppose you are drawing a matrix now, so you would be naming also it, because how do I address it? How do I call it? So I can call it by A, B, C. Okay, so if any matrix like question is given to me, or I am like answering in matrix, so I'll be naming also. I'll do the naming also for that matrix. Okay. So generally it is A, B, C, something. It could be anything. Okay, that's not a relevant point. And elements are denoted by like A, B, C. No, that is not true. Like that is partially true. Like we can call these elements by, like by A, B, C, D, E, F, G, H type. Okay, but there is proper address of an element. I'll be explaining to you like how does it matter. Okay, so suppose I have one matrix with me. Okay, so as I told that there should be a rectangular array or square array. Yes, this is an array because I can see that two elements are there, 2 and 3 and 4 and 5. Now you are not going to use numbers. Now you are going to use elements if you are talking about matrix. Okay, and we have that sign also which represents that it is a matrix. Yes, so we'll use general this notation to represent element of a matrix. Okay, so make sure guys, Aij is the address of element of matrix. Like how do we call address? How do we know address? Okay, so before that I would like to tell you that in matrix there are two things, rows and columns, as you can also see. So these are like the horizontal lines are known as rows and these vertical lines are known as columns. Yes or no? Rows and columns, like you already have that idea. Okay. So suppose in this, so I can see that there are 3 rows. Yes, there are 3 rows. So these green lines are representing rows. So this is my R1, this is my R2 and this is my R3. R1 means row 1, row 2 and row 3. And next we have blue lines which are representing columns. Okay. So this is C1, this is C2 and this is C3. So that is what we have discussed in like these 5 to 10 minutes, that a matrix is going to be a rectangular array of elements. Fine. In that array there will be the elements will be arranged in the form of rows and columns. Okay. And what are rows? That we already know, that the horizontal lines are rows and vertical lines are supposed to be called as columns. Fine. So first thing is order of a matrix. Okay, now I was discussing Aij also. Okay, so Aij means element of a matrix. See, if a single matrix is there, I will call it as matrix. But if there are multiple matrices, so I will call matrices. Okay, that is the plural. Okay, so Aij is, what is the role of Aij? Okay, suppose in this matrix you can see that 1, 2, 4 is there, 3, 0, 2 is there, 5, 6, 7 is there. Now suppose I want to talk about this 0. I want to talk about this 0. How do I call it? How do I address it? I'll use this notation, yes, A22, because I will see I here represent row and J here represent column. So the element of which you are talking about, you have to know the, like, in which row the element is placed, and know the column also in which column the element is placed. Once you know the row and column, then you can use this notation to address any element. So 0 is, I can see that it is lying in second row, okay, R2, and it is lying in second column, that is C2. So it will be A2 2. This 2 is for row, this 2 is for column. Now suppose I have 6. So first I have to write its row. So row is 3, so I'll write 3. And then its column. So column is 2. So A32. Very fast. Everybody is replying very fast. So A32, A32, A22. Fine. Good. Now suppose if I ask what is A23? What is that? A23 is 2. Fine. So we'll not be wasting our time over here on this discussion, because I am sure that everybody knows this. Fine. Okay. So first thing. So either in CBSE or in JEE, the first thing that we are going to learn in matrix is order of a matrix. So order of a matrix is usually what? It is M cross N. Okay. So just make a note. Order of a matrix, it is known as M cross N, where M is your rows and N is your columns. Like number of rows I should write. Okay, number of rows, and N is number of columns. So suppose a matrix is having 3 rows. That means number of rows is 3. That means M is 3. And it is having 2 columns. That means the value of N is 2. So the order will be 3 cross 2. You don't have to multiply. You just have to write in this manner only. Fine. I'm not talking about Mn. I'm talking about M cross N. So 3 cross 3 will be the order. 3 cross 2 will be the order. Or anything could be like that. Okay. See, the same is written in the definition. A matrix with M rows, N columns is to be of order M cross N. Read it as M by N. Order of a matrix is also known as type or size of matrix. Wow, very important points. Okay, as we can see in the definition. Okay, tell me what is the order of this matrix? 3 cross 3. Why? Because there are 3 rows and then there are 3 columns. 3 cross 3 is the matrix. Order of matrix. Okay. Okay. Please excuse me for a minute, huh? Yes. So we have this matrix. So order of that matrix is 3 cross 3. Okay. In compact form, the previous matrix is denoted by A is equals to Aij M cross N. See, now we have covered this. Like Aij is what? Aij is the element of a matrix, as I told you. Element of matrix. Okay. So I will suppose I will give the naming of that matrix to be A. So I can write it like this also, of M cross N. So what are the information that what is the information that I'm getting from this? I can know the order of matrix and I can know the elements also. Fine. Yes. Okay. So that was about introduction part, like what are matrices and why we are going to learn so much details about matrices. Now is the interesting part, types of matrices. So earlier we will be discussing about CBSE, the portion that is in CBSE also. Okay, but later on we will discuss the portion that is of strictly JEE. So that will not be like available in CBSE books. Fine. So there are, see, square matrices and rectangular matrices. So what is a square matrix? Obviously, if by any chance M is equals to N. What is M? That is number of rows equals to number of columns. So ultimately it will become a square matrix. So it will be like its shape will be of a square. Okay. And rectangular matrix, M is not equal to N. Suppose you have 10 rows but only 3 columns. So that will obviously, when you will write this in that manner, it will be like the shape will obviously will be of rectangle. Okay, see. Here we can see that 3 rows and 3 columns. Yes, 3 cross 3 is the order. And it is a proper square. Okay. But here we can see that there are only 2 rows. This is R1 and this is R2. But columns are 3. C1, C2, C3. So 2 cross 3 is the order. So when M is not equal to N, then obviously the matrix will take the shape of a rectangle. That is why it is known as rectangular matrix. And when M is equal to N, it is known as square matrix. Again, not like something which is very simple. Okay. See. In square matrix, M is equal to N, as I already mentioned. And in rectangular matrix, M is not equal to N. Fine. Okay, principal diagonal. Okay, there is this term which is very important. Principal diagonal of a matrix. So what do you mean by principal diagonal of matrix? See, diagonals is like if I draw a line which is diagonal, so it can be like this also, or it can be like this also, right? Like in square also there are two diagonals, correct? So the elements that are inside the diagonal are known as principal diagonal. For example, see in this matrix, so 1, 3, 4 are known as principal diagonal. Because I can see that these are the elements of a diagonal. And we will not consider the second one. We will not consider this one. Like 0, 3 and 0 we will not consider. Okay, because it is a notation, it is a standard that we have maintained that only these and these are supposed to be the elements of a diagonal. Okay, and it is also represented like this also sometimes. DIAG 1, 3, 4. That means a matrix who is having 1, 3, 4 as its principal diagonal. So it could be anything, but yes, 1, 3, 4 will be in the diagonal. I don't know like what is there. It can be A, it can be B, it can be C, it can be D, it can be E, it can be F. But 1, 3, 4 I know because this is written. Okay. Now this is very important, highly important, because I am having one question based on this concept also. So trace of matrix. This is not in CBSE. Trace of matrix. In CBSE book, nothing is nowhere is mentioned like what is trace of matrix. Okay, but we have some questions based on trace of matrix on JEE Mains. Advanced we don't have. Okay, on JEE Mains. Okay, the sum of all the elements of the diagonal is called as trace of matrix. So such an important term, you guys have to note it down. The sum of all the elements of the diagonal is called as trace of matrix. So now we have 1 with us, 3 with us, 4 with us. So 1 plus 3 plus 4. It is known, it will be 8. So trace of matrix is 8. Okay. So how do we represent this? We'll write TR. Okay. If I have to write trace of a matrix, I'll write TR and I'll write A. So that means trace of it. So it is 8. Okay. So these are the few details that you have to copy, that you have to note. Shall we proceed? Okay. Okay, before that, students, I want to ask one thing that is very genuine from my part also, because it will be helpful for both of us. Okay, you tell me, you guys are preparing for 12th JEE, right? So, what is the prerequisite of 12th JEE? That means there are certain topics that are covered in 11th in JEE. See, JEE comprises of two sections, na, 11th and 12th. So there are some topics that are in 11th, there are some topics that are in 12th. So I'll take care of that 12th part. That's not an issue. So, like, some of the students must be in school also right now. So are there any droppers? Like, are there some students like there, like they have covered, like they have completed their school? Someone is there? No, each one of you is going to school. Okay, so that means I have to like take care of each and every concept also. Because I was thinking that if there is if there is a lecture, so what we can do is we can incorporate as many questions as possible in the lecture. So for that I have to cut short the theory. So what do you say? Like, I should include both in a proper ratio, or I should like rise the number of questions? Okay, everybody please put your opinion on chat. Okay, I'll be back in 1 minute. Yes, I think more question is best. More the questions, we have better idea of how to solve, sir. Equal ratio is also fine, sir, or we can have session specific Q&A. Yes, that we have. I think you don't have. Okay, fine. I'll tell you how lecture is scheduled. See, in my lecture, what is there? There is a sufficient amount of theory, because it is very important to get all the concepts of theory first. And I do have incorporated questions also. Okay, and we can have all of these things like separate Q&A session also, separate theory also, DRS also. Everything is with us. But the point I was asking is, like, if, for example, particular session is going on, particular topic is types of matrices. So what do you want? Like, you just want theory, or you want directly question on that? So I think it is I was not knowing this, but as you guys told me that all of you are going to school right now. Okay. Like all of these things must be like you might have studied in schools also, right? Okay, this is something. So questions on this right now will be more helpful. Fine. So this is for this chapter, no? Like, so what if, like, if I start continuity and differentiability? So you know this because you might have already studied this in school, correct? According to me, I should bring theory with every topic. And yes, obviously, questions I will incorporate according to that. Okay, fine. Maybe you can ask us before each chapter and we can proceed according to that. See, there are some chapters which are like more of CBSE. Like in there is nothing of JEE also in that. So CBSE is the base. So I have to cover CBSE also now because there is a proper bridge between CBSE and JEE. That's okay. That's not an issue. See, like all of the things that I've told, I agree that there are certain things that you might have already known. But like this trace of matrix. So this is the proper JEE concept. So that is eventually there now. Okay? Okay. Yeah. Sorry, actually, I was getting a very important call. Yes. Okay. So moving on. Now we have another type which is diagonal matrix. So what is this diagonal matrix? So diagonal matrix is something like if we have the elements only in the diagonal and rest each and every element is zero. Like you can see in the example also. Okay. So 1, 3, 4 are in the diagonal. So this is known as a diagonal matrix. Non-diagonal elements are there. Each and every element is zero. Fine. Okay. Next we have scalar matrix. What do you mean by scalar matrix? Scalar means non-zero complex number. Non-zero complex number means what? See, in the place of elements now, like 2 is there, 0 is there. So 2 and 0 are real numbers. So it is a possibility that a matrix could be formed from complex number also. So if it is a if no complex number is involved, then it is eventually a scalar matrix. So there is no need to understand this type. So scalar matrix is every single matrix is scalar only. Okay. Unit or identity matrix. So what is this unit or identity matrix? It is very important. When each and every element is zero except diagonal and all the elements in diagonal is 1, that is known to be identity matrix or unit matrix. It is represented by I also. Okay, and see, it could be possible that it can be written as 1 0 0 1. It can be written as 1 1 1 0 0 0 0 0 0. It can be also written as like this, like 1 1 1 1. Now 0 0 0 0 0 0 0 0 0 0 0 0 0, like this. Okay, so this is of 2 cross 2, this is of 3 cross 3, and this is of 4 cross 4. So instead of writing this I should write I3 for this. So this 3 will indicate me what is the order of that matrix. Okay, So this 3 will indicate me what is the order of that matrix. Yes or no? Yes. Null or zero matrix is something in which each and every element is zero. Row matrix. So what do you mean by row matrix? A matrix if there like if there is only one row, no more elements are there, all the elements are placed in a single row. So that is a row matrix. For example, like this, like 1, 2 and 3. Only one row is there. Okay. And for example, column matrix. So 1, 2, 3. Only one column is there. So these are the related examples. So this is a row matrix and this is a column matrix. Because we can see that there is only one column and we can see that there is only one row. So row matrix means row should be equal to 1. Column matrix means column should be equal to 1. Or I should write number of rows. Okay. Upper triangular matrix and lower triangular matrix. Okay, fine. Suppose we have a matrix like this. So 1, 2, minus 3, 0, 4, 3, 0, 0, minus 4. So if we see the principal diagonal, so there are always two triangles beyond this principal diagonal. So this one is known to be a lower triangle and this one is known to be a upper triangle. Okay. So if all the elements in lower triangle are 0, so that is eventually upper triangular matrix. Okay, we can say that like this also, like there are elements like except diagonal, there are elements in only upper triangle. So that is why this is upper triangular matrix. And all the elements, rest of the elements like except diagonal and except upper triangle, all the elements are 0. Then it is the upper triangular matrix. And lower triangular matrix means obviously the elements will be in lower triangle only and the upper triangle elements will be 0, like this. See, A21 is there, A31 is there, A32 is there, and here you can see that these elements are 0. A12, A13, A23. Okay, so there is one important point also, like if you guys have noted this like Aij is 0, Aij is 0 for I is greater than j. Like you can always see that if a upper triangular matrix is there now, so it will be having elements always I is greater than j, like 2, 1, 3, 1, 3, 2. So always I will be greater than j in upper triangle. And if you talk about lower triangle, then it would be the reverse case, like 1, 2, 1, 3, 2, 3, like this. Okay. Okay, fine. Now transpose of a matrix. It's very important because it is highly used in each and every like question. Like most of the questions are solved with the help of transpose only. Okay. So what is this transpose of a matrix? Suppose I have a matrix like A matrix is there. Like 1, 2, 3, 4, 5, 6, 7, 8, 9. And I want to take the transpose. So transpose is always represented as A, T. T on the subscript. Okay. So what do we do in transpose? We just pull each row and create it as a column. Like 1, 2, 3 is supposed to be the row in the original matrix. This is R1. What you have to do is you just have to interchange rows and columns. So R1 will become C1 now in case of transpose. So I have to write the elements in C1. So that will become 1, 2, 3. Again for the same R2 it will become 4, 5, 6. So R3 it will become C3. It will become 7, 8, 9. So this is the A transpose. I'm sure it is clear. Everybody, this is clear, right? Yes. Okay. So we have some better examples also. Matrix obtained by interchanging the rows and of A into columns is called the transpose of A. Fine. Transpose of matrix A is denoted by A complement or A transpose. Yeah, this is the sign of A complement. This also represents transpose. Okay. Suppose we have this A is equals to 324107. So what will be A transpose? You have to just pick column and convert it into row. 340 is there, na? First column. So you write the elements in first row. So 340 will be there. After that 217 will be there. Okay, this is clear now? Fine. Okay. Properties of transpose of matrices. This is a very like common property. If A is any matrix and you take the transpose of that matrix and you again take the transpose of that matrix, so eventually it will be A. Like what you have done. Suppose a matrix is given to you. So you have interchanged the rows and columns. Now rows have become columns, right? And if you again do the same process, then again rows and columns will interchange. Na? So it will take the original matrix. It will be again in the form of original matrix. So that means transpose of transpose will be A. Fine. There is next property which is if A and B are two matrices, please note down because these are very important properties because we will be solving questions based on this. If A and B are two matrices of the same type, then A plus B whole transpose will be equals to A transpose plus B transpose. Like if there are any two matrices, either you add them first and then take the transpose, or you can simply individually take transpose and then add. The result will be same. This you can do also. This you can check also. Okay. Please note down. Then we have third property which is if A and B are two matrices for which conformability for multiplication is assured, then AB whole transpose will be equals to B transpose into A transpose. Okay, this I'll explain you like what is there. Suppose A and B is there. Okay, A and B are two matrices and you are multiplying this. So multiplication, I'll give you a clarity on multiplication also. Okay, guys, first you tell me, like, is multiplication of matrices clear to you? Please raise your hands. How many of you know how multiplication is? Like, how do we multiply matrices? Because in our lecture, in this lecture, there are many things which are directly related to multiplication of matrices. So if there is someone which is having any doubts, any issues in multiplication, so I have to tell that also, no, first. So just tell me, multiplication is clear to everyone? Multiplication of matrices? No. Okay. Fine. That's not an issue. We have a proper lecture on multiplication also. Okay. So don't worry. So for now we can say that if there are two matrices, okay, like A and B, and you multiply both the matrix, okay, then you take the transpose. So that will be equals to this. The transpose of second matrix multiplied by transpose of first matrix. Okay, so this will be not be equal to this. Okay, because commutative property is not there in taking transpose and then multiplying. So you have to like learn this because this is the very important property. We'll be using this in questions also. Fine. Okay, another very important property. if A is any matrix and K is any complex number, then KA transpose will be equals to KA transpose. Okay, what is this? Like if you multiplied any element in matrix, suppose, okay, I'll just give you a example also. Like if you are having A, suppose a matrix is there 1, 2, 3, 2, 1, 0, 1, 4, 1. Suppose like this. Okay. And if you multiply any number to this matrix, suppose 5A I am going to write. So what will happen is this 5 will be multiplied to each and every element. So this will become 5, this will become 5, this will be remain 0, this will become 10, this will become 10, this will become 5, this will again become 5, this will become 20, and this will become 15. Yes? So this is your 5A. So now if you take the transpose of this, like if I ask you to take the transpose of this, so it will be, I can write like 5, 5, 0, 10, 10, 5, and 5, 20, 15. Like this. Okay? Or if I directly take the transpose of this, like A transpose, it will be what? It will be 1, 1, 0, 2, 2, 1, and 1, 4, 3. And then multiply it by 5. So it will become 5, 10, 5, 5, 10, 20, and 0, and 5, and 15. See, the results are same. Yes? So that is the property. Okay. Is it clear? Fine. Okay. So this one is proper JEE concept. So Hermitian matrix. So is anyone here who is having some idea about Hermitian matrix? Harimesh, you know this? No. Fine. Okay. So let me tell you guys, like there are certain matrices. Okay. So now from this slide, there are some matrices which we are going to use only for JEE. Like, you know, you don't have to mention that in CBSE anywhere. Okay. So these are some of the matrices that I am sharing you the details of those matrices, like what do we call, like what is a Hermitian matrix and all and all. Okay, because there are certain questions which are directly from these topics. Okay, fine. Okay, so read that. A square matrix A is said to be Hermitian if the transpose of conjugate of A is equal to it. Again, I'm sure that there is nothing much that you have grabbed from this definition, so I'll explain you. Okay, so first of all, recently, like we were discussing about types of like when we started this discussion, types of matrices. So till now, whatever matrix we have discussed now, each and everything is of scalar matrix. Okay, each and everything is of scalar matrix. But now we have come to non-scalar matrix. So now these matrices will having complex number inside their elements. For example, see, if I have such kind of matrix, so A is what? 2, 2 plus I, 4, 2 plus I is a complex number. Yes, 2 minus I is a complex number. 3, I again is a complex number. 4 minus I and 1. So we can see that in the elements we are having complex numbers. Now you can't say that 2 is a complex number. 2 is not a complex number. 2 is a complex number. Why? Because 2 can be written as 2 plus 0i. Yes. So each and every element is a complex number. Fine. So if such kind of matrix is given to you, first of all, it should be square. Okay. So it is said to be Hermitian if it follows this property. Like you have to take the transpose of the conjugate. First you have to take the conjugate. Okay, so what is the conjugate? So conjugate will be, see, if there is A plus IB, conjugate will be simply A minus IB. This I guess you might have studied in class 11. So conjugate will be A bar. That is 2. 2 will remain 2 only because there is no imaginary part inside it. So it will become 2 minus I, it will become 4 only, it will become 2 minus I, 2 plus I, sorry. It will become 3, it will become minus I, right? Because I can be written as 0 plus I. You have to change the sign while taking conjugate between real and imaginary. So yes, the sign is changed for I. And 4 and I and then 1. Okay. Now if you take the transpose, so that means you have to find the conjugate first and then you have to take the transpose. And somehow if it came equal to original matrix, then it is a Hermitian matrix. Okay. See. So we have taken the conjugate and then taken the transpose, and you can see that the matrices are exactly same. So yes, A is a Hermitian matrix. Okay. Please note it down. Let me know when once you are done. Done? Okay. So we can see that while performing this, the original matrix is again retrieved. So that is why this is a Hermitian matrix. Now what is skew Hermitian matrix? Same. But after performing all the operations, it is equals to minus A. Not A but minus A. Then it is a skew Hermitian. So we have examples for that also. Suppose A is this matrix, minus I, 2 plus I, minus 2 plus I and 0. So what I'll do, I'll take the conjugate first. So conjugate will be what? It will be I, it will be 2 minus I, minus 2 minus I and 0. Now I'll take the transpose. So transpose is what? It is I minus 2 minus I, 2 minus I and 0. Now you can see, like in original matrix, this was minus I. But in new matrix, this is I. Okay? It is like minus A is there. If A is there and I am writing minus A, that means I am multiplying the matrix by minus sign. So the matrix will become I minus 2 minus I. This will become 2 minus I and this will become 0. See? So this is the same matrix that we have got after taking the transpose of the conjugate of matrix. So this is the skew Hermitian. So Hermitian and skew Hermitian. I am sure terms are clear to you. If anybody having any kind of doubt, fine. Okay. So note down another matrix, that is orthogonal matrix. So what is there in orthogonal matrix? Have you ever heard of orthogonal matrix? Anybody? No. Fine. A square matrix is said to be orthogonal if this kind of property exists. Now what is this? Like if A transpose into A is same as A into A transpose, and that should be equal to I also. Like I am having any matrix, I just take the transpose of that matrix, I multiplied both the matrices and the answer is I. Wow, this is now an orthogonal matrix. And also if this is happening, so this should also happen, like A transpose into A should be also equal to I. Okay, so this will be a condition for orthogonal matrix. Now for example, we will see that, for example, A is cos theta, sin theta, minus sin theta, cos theta. Fine. So I will take the transpose first. So transpose will be what? Cos theta, sin theta, minus sin theta and cos theta. Okay. I'll multiply A and A transpose. So when I multiply A and A transpose, okay, so students, please pay maximum attention over here. Although we have covered multiplication in the next session, but I am telling you multiplication right now because this is the need of the hour. Okay. For the students who are not having any idea of multiplication, please pay attention because this is something which is tricky. Okay. So I'll rather bring up a new page. Yes. Multiplication of matrices. Okay, suppose I have a matrix which is like 3 1 4 2 1 0 0 1 2. Okay, like this. And another matrix is B, which is like minus 1 0 1 2 1 0 3 0 2. Okay. So if I multiply AB, then how it is going to be? Like what will be the product? Okay, what will be the product matrix? This is the concern right now. So I would like to tell you that before we multiply matrices, we need to check whether the multiplication is possible or not. So this is very important to know that whether the multiplication is possible or not, because then only you can proceed for the multiplication, right? So how do we check this? So for that we will write order of both the matrices. Suppose the order of this matrix is what? It is 3 cross 3, and order of this matrix is 3 cross 3. So if the number of columns in first matrix is equal to number of rows in second matrix, then multiplication is possible, else not. The condition is clear? The condition is clear? That means if I am having a matrix like 2 cross 4 and I am having a matrix 3 cross 3 and I am trying to multiply both the matrices, the multiplication is possible? No, because this 4 and this 3 are not equal. Okay? Okay, fine. So first thing is to know whether the multiplication is possible or not. Second thing is, if it is possible, then what will be the product of order matrix? Sorry, what will be the order of product matrix? Suppose AB is my new matrix now. So I should be knowing the order of that matrix now before multiplication. So order of that matrix will be this. Number of rows in first matrix multiplied by number of columns in second matrix. So that is again 3 cross 3. So this will become 3 cross 3. Okay. Now how do we multiply? See. So I'll suggest you guys to write down the elements first. So you have to fill, like you know the structure of matrix. It is 3 cross 3. So it will have 9 elements. So it will be A11, A12, A13. Okay, first row and third column. This will be A21, this will be A22, this will be A23. This will be A31, A32 and A33. Now please pay attention. Why I am writing this? Because this is going to make your work easy. Okay. Visible? Okay, see. So A11 is there. Okay. So A11 means this one is row and this one is representing your column. Again, this is for M1. This is for M2. That means the first you have to take for matrix 1 and the second you have to take for matrix 2. So I'll take the entire row of matrix 1 and take the entire column of matrix 2 and multiply and add the elements. So this will be, what will be A11? It will be 3 into minus 1, 1 into 2 and 4 into 3 and then plus and then plus. This is A11. That is minus 3 plus 2 plus 12. 12 to 14 minus 3 is 11. So A11 is 11. Okay. Now suppose I have to find A32. So what will be A32? So A32 will be, we have to look for third row in matrix 1. So third row is this. And 2 means we have to look for second column in matrix 2. We have to look at this. So 0 into 0, 0 into 0, and then 1 into 1, 1 into 1, and then 2 into 0, 2 into 0, and then add. So 1, 0, 0, so this will be 1 only. So like this operation you have to perform 9 times because you have to do it for each and every element, right? Yes. So this is how we proceed for multiplication. Okay. Okay, students. So I think we should take a break now. Okay. So I'll be giving a 10 minutes break to all of you, and I'll be back after 10 minutes. So we'll resume the session after 10 minutes. Okay. Yes. Okay, everyone. So yes, please turn on your cameras once again. Okay, fine. Yazira, you tell me multiplication is clear to you? Fine. So we'll do that multiplication one more time in this question. Okay. Okay. So we have to check like is this matrix is a orthogonal matrix or not. So for that we have to first take the transpose. We have taken that A transpose. Now we have to multiply A and A transpose. Okay. So that is directly I have written 1001. But I will be telling you how this has like came where this came from. See. The order for this matrix is what? 2 cross 2. And this is also 2 cross 2. And we can see that this and this are equal. So that means the order will be 2 cross 2. First of all, multiplication is possible and the order for product matrix will be 2 cross 2. So yes, the matrix will be 2 cross 2. That means it will have A11, A12, A21 and A22. Okay, these 4 elements will be there. So what will be A11? A11 is just take the first row from the first matrix, that is cos theta. That is this row, this row. And this column you have to take. So cos theta into cos theta you have to take. That is cos square theta. And plus sin theta into minus sin theta. So that is cos square theta minus sin square theta, right? It will be minus sin square theta. Okay. I think something is wrong. Wait 1 second. Because we have 1 0 0 1. So I have to check this multiplication first. Okay, everybody please do this multiplication, and I'm also checking this. No, the multiplication is right, but actually this is there is this problem. This is not A transpose. So yes, there is a error in there must have some typing error. That's not an issue. Fine. We can do this question. Okay. See how we are going to do that. So A transpose will be, first of all you have to find A transpose. So A transpose will be, you have to take the transpose for this matrix. So cos theta sin theta will be like this, cos theta and sin theta. And then minus sin theta and cos theta, minus sin theta and cos theta. Okay, yes. Now if you multiply this by A, like here I have to write this matrix cos theta sin theta and minus sin theta and cos theta. This is A, and you multiply this by A transpose, that is cos theta minus sin theta will be here and sin theta will be here. Yes, now it will be true. So it will be 1 0 0 1. Yes, you can do this, like A11 will be what? Now it will be cos square theta plus sin square theta, right? That is all of us know that is equal to 1. So yes, we have got that identity matrix. So that means this condition is fulfilled. That means this is an orthogonal matrix. Okay. Please everybody please take a note of this. And rest of the participants, please turn on your cameras. Okay, noted. Just let me know once you are done. Okay, fine. So next we have unitary matrix. Now what is this unitary matrix? A square matrix A is said to be unitary if A, this is what sign they have used. Fine. This is if A transpose into A is equals to I. Okay. Sorry. So this is that, okay, fine. Because A transpose into A is orthogonal. We have just discussed, right? Okay, A star they have used. Okay, A star is simply this operation. Like if you, the operation that we discussed in Hermitian matrix. Like if you take the conjugate and then take the transpose. If this thing multiply the original matrix is I, then it is known as unitary matrix. Okay. You can just write the property only. What is the condition for unitary matrix? What is the condition for orthogonal matrix? What is the condition for Hermitian? What is the condition for Skew Hermitian? Okay. In this manner, you can do that. See, now we have, suppose this is the A matrix. So first what we have to do, we have to take the conjugate for this matrix. Okay. When we take conjugate, this will be this. Now I have to take the transpose also. So now conjugate will be this. Now I have to multiply these two matrices. And if the product is I, then it is said to be unitary matrix. So if I multiply this now, so yes, that will be same. Product will be 1 1 1 0 0 0. I'm not doing this because it will waste. It will be a waste of time. Okay. So that will be unitary matrix. Note it. Okay. Okay. Next, this is very important matrix. That is idempotent matrix. So a square matrix is said to be idempotent. This is not involutory. This is idempotent. Idempotent. Yes, a square matrix A is said to be idempotent matrix if A square is equals to A. That means you are having one matrix, okay? And if you do the square means you have to multiply the same matrix by itself, and the answer is still A. Then it is said to be idempotent. Clear? Please note it down. So like we have considered one example also, that A matrix is there, okay, and we have multiplied it by again A. So A square is the same. So that is why A is idempotent matrix. Okay, so you just have to note down the names of matrices and then you have to write down the conditions. Okay, because in questions these are the some frequent terms that are being used, like idempotent matrix, Hermitian matrix. So you must be well aware of the things first, na, in order to solve the question. Fine. Okay. Now involutory matrix, another very important matrix, and there is a common confusion of students between these two, like what are involutory and what are idempotent. See, in idempotent the case is A square is equals to A only, but in involutory A square will be equal to I. Okay, suppose I have this example, like A is there, A matrix is there, and I square this matrix, like multiply the same with the another matrix. Okay, and the answer is identity. So yes, now A is an involutory matrix. Okay, so only the name of matrix and the condition you have to write. Copy this and just give me a thumbs up once you are done. Done? Fine. Okay. So guys, we have covered all the topics. Okay, now we'll be solving some questions. Okay, are you guys ready? So only this much was there in the first session. of matrices as per the JEE. Now we are back with some questions which are directly from JEE Main. Okay. So just analyze what is the level of question and what are the terms that are being used in question. Okay. So in the session, let me just have a quick overview. What we have discussed till now, the basics of matrices, okay, and the types of matrices. That's all. Okay, and some properties also. So the question is, A is equals to this and B is equals to this, but TR of A is equals to TR of B. Now what do you mean by this line? I've told you now, like TR of A is what? It is trace of matrix. Trace of matrix. Okay. Trace of matrix. And what is TR of B? Trace of matrix B. Fine. Okay. So the question says that trace of matrix A is equal to trace of matrix B, then find the value of 1 upon alpha plus 1 upon beta plus 1 upon gamma. Okay. So you have to find the trace of matrix A first. Okay. So I'll be doing this question. So what will be TR of A? As I can see, what are the elements of diagonals? Alpha square, beta square, gamma square. And what do you mean by trace of a matrix? In trace of a matrix, you just have to add all the elements of diagonals, right? So I'll write alpha square plus beta square plus gamma square. Is there any sort of confusion? No. Fine. What will be TR of B? That is trace of B. So I'll write 2 alpha plus 2 beta minus 3, right? 2 alpha plus 2 beta plus 2 gamma minus 3. Okay. And now the question is saying that both are equal. So I'll write alpha square plus beta square plus gamma square equals to 2 alpha plus 2 beta plus 2 gamma minus 3. Right? According to my question, this will be the equation, right? Now I have to find 1 upon alpha plus 1 upon beta plus 1 upon gamma. That means by the help of this expression, I have to find the value of this expression. So how many of you are able to solve this? Tell me how many of you are able to solve this? Okay, I'm giving a 1 minute window. Just try to solve this, okay? After that, I'll be solving it for you. Okay, solve everybody. Has anybody got the answer? Has anybody got the answer? Okay, so let me solve this one, okay? So the condition is alpha square plus beta square plus gamma square is equals to 2 alpha plus 2 beta plus 2 gamma, and minus 3 is over there. Okay, so I can analyze a pattern. Okay, see, what is the pattern over here? Alpha square plus beta square plus gamma square. is equals to 2 alpha plus, no, I guess 2 alpha was there only, not alpha beta. Yeah, 2 alpha plus 2 beta plus 2 gamma minus 3. Yes. Okay. So can I just write this as alpha minus 1 whole square plus beta minus 1 whole square plus gamma minus 1 whole square is equals to 0. Like when I shift these terms to the left hand side, so what will become? It will become alpha square plus beta square plus gamma square minus 2 alpha minus 2 beta minus 2 gamma plus 1 plus 1 plus 1 is equals to 0. Like this, right? So if I shift all the terms on the right hand side to the left hand side, so it will, now I can analyze this pattern now. Like if I somehow club this alpha square, this minus 2 alpha and this plus 1, so it will become alpha minus 1 whole square. Again this beta square, this 2 beta and this plus 1, so this will become beta minus 1 whole square. This gamma square minus 2 gamma and 1, so this will become gamma minus 1 whole square. So now I can clearly see that these are three positive integers. Why positive integers? Because alpha minus 1 square is there. We know that square of any number can't be negative. So that means this will be also positive, this will be also positive, this will be also positive. And any three numbers will never add up to 0. Any three numbers will never add up to 0. So if the sum of three numbers is 0, that clearly tells me that all the three numbers are 0. That means alpha minus 1 whole square is 0, which brings me to alpha minus 1 is equals to 0, which brings me to alpha is equals to 1, which brings me to alpha is equals to beta is equals to gamma is equals to 1. Now what was the question? The question was about to finding the value for 1 upon alpha plus 1 upon beta plus 1 upon gamma, right? 1 upon alpha plus 1 upon beta plus 1 upon gamma, right? We have to find the value for this expression. So it will be 1 plus 1 plus 1, that is 3. Easy. This was a question from JEE Mains 2020. So what actually they do in a question? They just put a very phenomenal term in the question, like trace of a matrix. So half of the students are not knowing about this trace of matrix. So that is why they skip the question. Okay, so it is very important to go through the theory for any topic if you are preparing for JEE. Please note the solution and then we will move to next question. Give me a thumbs up. Okay. Everybody has noted the question? Fine. So next question. Okay, this we have discussed. Now this question. Let A be a matrix which is A, B, C, D and B be a matrix which is alpha, beta, such that AB is equals to B and A plus D is equals to 20, 21. Then the value of AD minus BC. Okay. Try this one. Okay. Try this one, students. So what you have to do, you have to find AB first, because the condition is mentioned as AB is equals to B and A plus D is equals to 21, which is something which we are going to use like at very last. But AB is equals to B is there now. So in order to use that condition, we must find AB first. Okay, so AB will be what? Like we have this matrix A, B, C, D, and we have this matrix alpha, beta. Okay. So 2 cross 2 is there and alpha, beta, that is 1 cross 2. 2 cross 1, sorry. 2 rows are there and 1 column is there. Yes, multiplication is possible and 2 cross 1 will be the order of product matrix. Okay. So this will be A11 and this will be A12 A11 will be first row and first column. A21, not 1, 2, A21. Sorry. Yeah. Okay. So A into alpha, that is A alpha and B beta. This will be the A11. And what will be A21? So C alpha plus B beta. Okay. So this is your AB matrix. Now once you put this AB matrix which is equals to B, so that means A alpha plus B beta you are putting equal to, what is the B matrix? B matrix is alpha only. Like if two matrices are equal, then what you do? You compare each and every element, right? Corresponding elements are equal. So corresponding element, this is the first element now in AB. So what is the first element in B? That is alpha. So it will be equal to alpha. This is your first equation and this is your second equation. C alpha plus B beta is equals to beta. So now from these two equations, and the third equation is this. From these two equations, you have to find the expression AD minus BC. I am giving you again 1 minute window. Try to solve this and then we'll back. Has everybody got the answer? So alpha and beta I got as 0 or 2. Okay, alpha and beta you have got. Why alpha and beta will be 0 and 2? I don't know, by the way. I'll solve. Okay, see, look at the two equations very carefully. A alpha plus B beta is equals to alpha. I'll write this on a separate page. A alpha plus B beta is equals to alpha. And C alpha plus D beta is equals to beta. Okay, these were the two equations. Okay, so there is one relation. This is very common in maths. So I am going to tell you a technique that you have to follow, irrespective of any topic. While you are solving maths, this is a proper this is a proper method I can say, or proper standard I can say. Like what you have to follow is, I can see A is there, B is there, C is there, and D is there. So A, B, C, D are the four variables of same family. And then I can say alpha and beta is there. So alpha and beta are from different families. So you have to keep the two families along. Like if A alpha is there, B beta is there, you somehow need to separate this alpha from A and beta from B. Because all the like variables will be in one side and all the unlike variables will be on other side. So I can manipulate this equation A alpha plus B beta is equals to alpha, as I can bring this alpha to left hand side. So A alpha minus alpha, and I can shift that beta to the right hand side, so it will become minus B beta. Again I can take alpha as common, so it will become A minus 1 is equals to minus B into beta. Now alpha and beta can be on same side, so I can write alpha over beta, which is equal to what? Minus B over A minus 1. See now what we have got? We have got the variables of two families on same side. Now alpha is with beta only and minus B and A are on the same side. So this is the thing that you have to do while solving a question. Again we will do the same thing for the second equation. So C alpha plus D beta is equals to beta, right? This is given to you. So now what we can do? Yes, d beta. Again, d beta minus beta can be written is equals to minus t alpha. Yes. So beta can be taken out as common. So d minus 1 will be equal to minus t alpha again. 1 over minus c is equals to what? Alpha by beta again. Now this is also alpha by beta. This is also alpha by beta. So we can see that d minus 1 upon minus 3 can be written as equal to minus b over a minus 1. Yes. So just cross multiply these two. So a minus 1 times d minus 1. A minus 1 times d minus 1 will be equals to bc. Okay. Because bc is there now. Minus b into minus c, it will be plus bc. So now what will be the result? It will be AD minus A minus D yes. No. I think I have multiplied it wrong. Yes. See, it will be A times D minus 1 minus 1 times D minus 1. Yes. Is equals to BC. So it will be AD minus A minus D. Oh, I was doing right. Plus 1 is equals to BC. Yes. Okay, fine. So this will be shifted to this side. So this is AD minus BC and this can be shifted as A plus D minus 1. So now we have got this expression. So AD minus BC is equals to A plus D minus 1. This is the answer. Now what was the question asking to us? It has given me that A plus D is equals to 2021, right? This was given to us 2021. So we can minus 1. So the answer is, the value for this A plus D is 2021. It was given in the question itself. So 2021 minus 1, it will be 2020. So this is the answer. Okay. Students, clear? How was the question? It was a good question. Yes. So note it down. Okay. So you have covered this question. Now, okay, this I am giving it to you. You have to solve this question, okay? The question says, let M be a 3 cross 3 matrix which is satisfying these conditions. What is the sum of diagonal entries of M? That means you have to find the M matrix only. This is the question all about. Once you are able to find the diagonal matrix, then you can easily take the sum now. Fine. So I'll give you one hint also. You don't know what is M matrix. You have to find M matrix, but you know that it is a 3 cross 3 matrix. So you can take M to be a 3 cross 3 matrix and you can write it like A, B, C, D, E, F, G, H, I. Okay. Because I know that it is going to be a 3 cross 3 matrix, so I will simply put 9 elements in this matrix. This is my M. Now, if I multiply M by 0, 1, 0, that means if I multiply it by 0, 1, 0, so the answer is going to be what? The answer is going to be minus 1, 2, 3. Minus 1, 2, 3. So perform this multiplication and then compare. So first condition, second condition and third condition. After the execution of 3 conditions, you will easily find the values of A, B, C, D, E, F, G, H, I. And then the answer will be A plus E plus I. Okay, this is a very simple question, but yes, I agree, it's a lengthy one. So you have to solve it on your own. This question is again from JEE Mains. Okay, so try this and let me know the answer. So I'm giving a proper 3 to 4 minutes for this question. Okay, just let me know the answer. Okay, students. So I've assigned 2 tests to you. Okay, please check your respective dashboards. Class assessment and homework test is assigned to all of you, and you have to go through the class assessment. Okay, in this next 20 minutes. Okay, so attempt this question as well and the questions of class assessment also, and I'll discuss this all the questions after like 10 to 15 or 20 minutes. Okay, and everybody please give me a confirmation, give me a thumbs up like if tests are visible or not. Visible. Harimesh, is it visible? Sure. Tests are visible. Fine. So students, you have to attempt this question also, and obviously the class assessment. And I'll be discussing this question after a 10 to 15 minute gap. And yes, we have one more question which is from, see, you can see in the screen, that is from JEE Main 2021. You have this question also. This is very easy. I don't know why it was in JEE, but you have to attempt this one also. Okay. Please note this question as well, and we will be discussing each and every question after 15 minutes. Fine, just go through the questions and let me know. Okay, I'll be back. Okay, everyone. So quickly turn on your cameras so we can discuss the questions. Okay, and we are at the last part of this session. So quickly turn on your cameras so that we can discuss the solutions also for the given questions. You guys tell me, like, there were so many questions. Like, are you able to solve questions? Fine. Okay. So the answer to this question, like, has anybody got the answer for this? Okay, this is saying that A transpose is equals to I2. Now, this means that this matrix is what? I've told you, that if the orthogonal matrix, condition for orthogonal matrix, like the matrix and its transpose is equal to identity. Fine. So what we can do is, A is our 1 minus alpha, alpha and beta. So A transpose will be 1 minus alpha and alpha beta. So if you multiply this, so A transpose will become, yes, the multiplication is possible, obviously, because 2 cross 2 and 2 cross 2 is there. Okay. So the order will be 2 cross 2 only. Now 1 into 1, this will be 1 plus minus alpha into minus alpha is 1 plus alpha square. Okay. And first row, second column, so 1 into alpha, that is alpha minus alpha beta. So this will be the second element. A21 will be second row, first column, so alpha minus alpha beta. And last will be beta into beta, that is beta square. Now this is also, we know that this is equal to what? This is equal to 1, 1, 0, 0. Because I2 is mentioned, and I've told you that I2 is representing identity matrix of second order. Second, I know that 1 plus alpha square is equal to 1. So that means 1 plus alpha square is equal to 1. That means alpha is equal to 0 only. Right? And I can compare beta square is equal to 1. So beta is equal to, that brings me to beta is equal to 1. That's all. I think that is the answer. Alpha raised to power 4 will be 0 raised to power 4 plus beta raised to power 4 will be 1 raised to power 4, that is 1. So this was a very easy and smooth question from JEE Mains 2021. Right? This type of questions came sometimes. But you should be that much lucky. Fine. So, I've given you this question also, right? Has anybody got the answer for this? Actually, I have explained you the process. So you have to do it on your own only. Okay, because right now we are not having that much of time to spare on this question. You know the process now? There are just 3 conditions. What you have to do? You just have to multiply 3 times. The M matrix that we have assumed, you have to multiply it by this, yeah, this first condition. So some entries would be there, and then you have to perform this multiplication, and then you have to perform this multiplication. So it will be like give you the answer. Fine. Okay. Now this is something very important for CBSE as well as for JEE, because this question same has been occurred in CBSE also. Express the following matrices as the sum of symmetric and skew symmetric matrices. Okay, I am sure that in this session we haven't discussed what are symmetric and skew symmetric matrices, right? Right? I'll tell you what are symmetric and what are skew symmetric matrices. See, or should we like do this question in next turn only? Because in that turn we'll be discussing about the theory also. So we can place this question in second session also. Yes. Yeah, because it will take like a little more time to explain these things, symmetric and skew symmetric, and what are the formulas, like how do we can express any matrix in the form of symmetric and skew symmetric, so on so on. Okay, everyone. So I'm sure like everything that I told you in this session, like types of matrices and all, everything is clear, every question is clear. Just go through the class assessment questions, just go to the homework questions, and don't take that much of pending to you. Okay, if there is something assigned to you in previous week, you must get it done by the end of next week. Okay.